want the water or wastewater coming from those trenches or that drain field to travel through at speed sufficient to move from the site, because we don't want water to accumulate, but yet we need to balance that with treatment.
Welcome to the Fine Homebuilding Pro Talk podcast, our regular discussion with building industry professionals. This is Senior Editor Patrick McComb. I'm joined by Dr. Erik Severson. He's an Extension Associate in the Wastewater Management Training Program at North Carolina State University. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Dr. Erik, it is such a pleasure to have you on this show. I made an appeal to our listeners to put us in touch with a soil scientist, and they recommended you. And first off, like I ask everybody, are you healthy? Is family okay? Are you able to work normally? What's going on?
We're healthy, and wealthy is optional, wise is optional, but we're healthy, and we are operating under the new normal, which is the remote sense. We're trying to put things online as much as we can, and we're trying to telework as much as we can. The kids are taking online school, so that's been a new challenge. So we're making it.
Have you heard if your kids will be going back to school in the fall yet?
They have an option. We go year round here, so they have an option to go back July 17th, and that's the debate now. Whether or not to send them back. They need the socialization, but we also need them to stay healthy and us to stay healthy.
Sure. Can you please tell me about the university program that you're part of and what you do there?
Yeah, I am the training director of a wastewater management program that has been developed years prior to me being here. So I was actually a grad student at NC State back from 01 to 05. So I took an extra couple years, but
that's the norm with the people on the show, I can tell you.
That's right. That's right. More only to collect more wisdom, right? So this on-site, the science of on-site has really been, nucleated, if you will, in the early 70s, as far as I understand, early 70s, late 80s. And there was a vision, Dr. Michael Hoover, he of the Extension Service, Cooperative Extension Service, where we're kind of working hand in hand with state. And he had the vision, and he had the wherewithal to make a training program happen. And so we have a 33-acre training program, a facility off of Lake Wheeler Road, which is about 5 miles south of campus, give or take. And we have another one in Asheville in Mills River. There used to be all kinds of satellite training centers throughout the state. So he created that. Another person of interest is Dr. David Limbo. They worked together. I was David Limbo's first student. So it was really Dr. Hoover. He created it. He got the energy, he got the money, and he really founded. He really began the wastewater program in the early 90s, 95, 94.
Do you guys actually have systems that people train on at those facilities?
We have above ground displays at all the facilities, and we partner with local health districts and health departments and local operators and installers. So we work together, and these are, the curriculum has been, it was nationally based. There was a national curriculum around 03, 05 that was circulating around. And of course, 08 hit, so things kind of dropped down. But this curriculum was developed in 03, 05, that era. And we just built upon that.
And so are you training the people who are the system installers or the designers or both?
We provide a certification school for septic installers, operators, point of sale inspectors. So every time you get a home transaction, the lending institutions are asking for an inspection of the drain field. So inspectors in that regard, not the inspectors. It's a ubiquitous term for health department. Okay, so we don't do that. That training does go on at our facility, but that's through the state of North Carolina.
And are you guys doing research too, in addition to training these people?
Yes, I'm involved. Primarily, we're training. Our function is training. My directive is training, but I'm also involved in cool research projects. For instance, with other faculty in NC State, and we are looking at the effects of sea level rise on coastal systems, and because they are really at, I would say, at a higher risk because the elevation is not very great, especially out on the Outer Banks on the beach. You have,
So
you
we should
know,
tell listeners that North Carolina has a series of barrier islands off the East Coast, the Outer Banks, and they wash away pretty often, right?
yeah, and they have to be replenished and
Yeah.
renourished. And storms come through and create, move the sand around. And they oftentimes erode sand, there's been many instances of septic systems that are beachfront, relatively beachfront, right? They've been eroded away from storm surges. The storm surges are increasing, and this is also infecting the coastal people, not strictly, on the barrier islands, but people along the coast as well. Um, so,
Wh-
oh,
why should people care about this stuff?
people should care because half of America is on a septic system. Half to 40 to 45, roughly 45% of North Carolina is on a septic system. If you do not have a septic system, you do not have a livable dwelling or an habitable dwelling or business or facility. If you build a house and you can't, if you do it the opposite, if you build the house without the permitting and the soil information, you're left with a nice big shed, right? You can't get permanent power, etc.
I remind people too that as far as like the expensive systems in your home, this is it close to the top or at the top of the list. Am I right?
Depending on the home. So a lot of people, they can spend more on their draperies and curtains and then they can on a septic system, right? So it's one of it's considered foundational, or the term is escaping me, but it's concerned a vital portion of the home's infrastructure. So they can be very expensive. Yeah, they can be, but without them, you can't live there. So
I also tell people, frankly, this stuff interests me greatly, and many people think it's odd, but I tell them that basic human sanitation is done more to improve the human condition than anything else I can think of, right? We used to have regular cholera outbreaks and dysentery outbreaks, and we've largely got a handle on this because we know how to deal with our wastewater, right?
absolutely. In 1920, there's a chart I like to use in my courses that over thyroid or cholera infections per year over time, and it drastically decreases at 1920, whenever we started adding chlorine to the water, when we made the realization that yes, we need to treat water, and that really dropped dramatically throughout the years in the number of cases.
You mentioned earlier that you train these folks in these respective roles in inspecting septic systems and installing them. Can you tell me briefly? I know the rules are different state by state, but what are the classes of folks we're talking about in your program?
Okay, so with the broad spectrum of wastewater management, we're dealing with human waste. We're not dealing with animal waste. So with human waste, you have surface irrigation operators. That's the spray fields. That's the reuse of water for spray fields.
We should tell folks who aren't familiar with agriculture, but a lot of farms spray the manure on the crops, right?
Yep.
Yeah.
And so there's the spray. So when residuals are generated, there's liquids and solids. So you have to have ways to deal with both, right? So the surface irrigation is it's regulated under a state agency. It's called WIPSOC. I'm not going to bore you with the
I tried to figure out what those all meant.
No, don't try. So there's the spray irrigation operators, which deal with the surface application of waste that's been, 2% solids, 1%. And so it's a majority liquid that they're putting out there. And they rely, the sites are permitted and they rely on the crop and nutrient and evaporation, of course. Then there's the biosolid applicators, which is considered the residuals or the solids, what's left of these treatment of wastewater, small wastewater treatment plants, small up to large facilities. These can be the city of Cary, the city of Raleigh,
Hmm.
that generate a lot of waste, as you can imagine. And so you have to get rid of the waste. You have to be able to store it. So there's a big. It's may seem well, I don't know what it may seem like, but it was a big industry, and it's you have to deal with your waste.
Mm.
These are wastewater treatment plants. What do you do with all that material that comes in? You've got to screen it, treat it. It's a lot. It's very intense.
Where does it go ultimately?
Ultimately, it's either discharged into, bigger plants discharged into the river, right? But the solid portions and the byproducts of the treatment, they have to be dealt with, and they can be quote unquote shunted off into another direction where they are further separated liquid to solid. Smaller towns, less than 50,000 people, they have their own package plants, and they're smaller in scale. Same thing, they can go to lagoons that hold waste, the liquid waste, and then the liquid effluent is drawn from that lagoon and then sprayed onto these fields.
What about in the residential sector? So are
Okay,
these folks
okay.
putting pipes in the ground?
Yeah, I mean, so okay, all right, let me back up. So you have the surface irrigation operators, you have the biosolids or the land application operators, you have then the subsurface, which is the drain field portion. You have that class of operator. And what operators do, they maintain and monitor the systems to keep them healthy, keep them running. Now, then there's another entirely different regulated body called the installers and inspectors. And these deal with the subsurface. So anything below the ground, they are putting in systems, they are repairing, they are doing point of sale inspections. So they're a different body, different people.
When when they come to you for training, do you find that they're pretty knowledgeable, or are you starting from with a blank slate?
Well, unfortunately, I have to assume that they start from a blank slate, but most of them do come in with some kind of machinery operation,
Yeah.
able to operate equipment. They're familiar with business. A lot of them come from the grading industry where they'll see someone else putting in the septic system. They will clear the lot and they will see someone else see this put in the system and say, hey, I can do that as a part of my services. Um, and you have people from existing businesses looking to branch out, looking to do add different thing skills or services that they offer.
What does the state require folks? How much training to be certified to do residential septic maintenance and installation?
Okay, so the installation port, you have to go through at minimum an 18-hour introductory class, and that involves classroom and field portions of learning. So we're just, again, that is the minimums. We're introducing regulate, it's a rules class where they have to know their bounds. This is not a class where we get out there and they're operating the machines. That we're not set up for that. This is a rules class where they get a taste of what's going on. We try to give them as much information within a 3-day period as possible.
You're teaching them things like how far away the drain field has to be from a
Setbacks,
water supply or property lines, what have you.
yes, the minimum stated in the sewage regulations. So that, just like that.
So are these the same folks in North Carolina that are designing systems, or is that another entity
No,
typically?
they're two entities. One is the health department. Well, three really. The health department, they're public sector employees. They go out and they have traditionally designed septic systems, and then they will issue the permits. Nowadays, the health department, in addition to the health department, licensed soil scientists will go out and evaluate the soils, and they will design the system and then submit, a package to the health departments. Now we're in kind of a transition where there's new regulations being proposed, new session laws being introduced. So there's a lot of options. You also have an engineered option where engineers can come in and design and kind of take control over the system, if you will, from cradle to grave. Um, so they're engineers, soil scientists in the health department.
So in septic system design and function is dependent on having the right kind of soils, right, and a healthy microbiome. What are the characteristics of like good soil for a conventional septic system? And we can get into what a conventional septic system means in a little bit.
Okay, so the best soil, ideal soil, is one that's well drained, that's deep, that's not, it's, you don't encounter bedrock or restrictive layers or seasonal wetness. It's permeable, and I guess I'll qualify that it's moderately permeable or moderately rapidly permeable. It's ideally you want the water or wastewater coming from those trenches or that drain field to travel through um, at speed sufficient to move from the site, because we don't want water to accumulate, but yet we need to balance that with treatment. That we count on the soils to act as a final treatment process. Okay, that's the soil is the number one treatment facility in the world, right? So we're counting on the soil, and specifically the oxygen in the soil, to break down and renovate that effluent, because these are essentially reuse systems. They're going, that water or liquid portion is either going to be absorbed by the soil or move into groundwater, right?
Mm-hmm.
So we need it to, the clays and the soils and the fine particles to remove and to attach the nutrients and the pathogens to attach to the clay, to treat the effluent. So the ideal is a balance. The ideal, we call it sandy clay loam. That's pretty much the ideal. There's a texture triangle from the USDA. Might be getting off the weeds, but a soil that's permeable, deep, well drained, but not straight sand. Straight sand it's great for disposal, but not treatment.
If I'm correct, the water just flows through it too quickly. You don't get the microbial action in the soil to break down the pathogens.
You don't get the residence time. You're too quickly is bypassing. And I want to mention also landform or landscape. The way that the land shape really dictates what type of soil you have, in part, and it also promotes the water moving or shedding away. You do not want it to accumulate. And like, you don't want to put your drain field in a bowl. You want to put it on a nose slope where water's shedding off in three directions, ideally.
Interesting. So I mentioned conventional septic system, right? And I'm going to walk through. So there's a tank, right, that catches solid waste. And then there's an outlet on the end of the tank, and it goes to a drain field, right? And the water percolates through the soil and gets purified. Am I correct in that kind of?
Yeah, there's generally four basic parts. There is the home or the source or the facility, and there's a pipe, a PVC pipe from the home to the tank. Now that pipe from the home to the tank, that's governed under plumbing code. Okay, so when it hits that inlet portion of the tank, then it becomes under the state rules, the septic rules. And so it flows into a tank, and then the solids settle out, and there's an inlet and an outlet side, and there's a baffle, there's a wall. So the inlet side, the tanks are, give or take, 1,000-gallon tank is about 9 feet long and 4 feet wide. And it's about, let's just say 6 feet deep. Maybe 5 to 6 feet deep, right? Depending on the tank. And so that wall inside separates the solids and it holds it back and allows for stratification of the scums, which is the fats, oils, and greases, which flows to the top, and then the heavies sink to the bottom, the solids, and then you're left with this clear layer. So, the function of a tank is to stratify, to reduce the solids. There's some anaerobic decomposition going on. And to hold it right. So the inlet side is 2/3 of the entire tank, and then you have the outlet side. And on the outlet, there's two access points, and on the outlet, you have a filter which further removes total suspended solids and organics.
And that's can I say, a relatively new addition to conventional septic systems, or is that incorrect perception on my part?
Well, in North Carolina, after January 1st, 1999, every septic system is required to have a filter.
And that's meant to keep solids out of the leach field, right?
That's meant to protect any downstream component of the drain field from organics. So
Yeah.
from that tank, you could flow by gravity into a pump tank. You could flow into a distribution box. You can flow directly into the drain field. There's many different configurations.
And people want a conventional system largely because it relies on gravity. There's no pumps, and they're relatively inexpensive compared to some of the systems that you need for more problematic soils. Is that correct?
Okay, well, yeah, there has been a historical bias against pump systems, or quote pump back systems. Yeah, people ideally would like the easiest system there is. Gravity system flows by gravity. There's no moving parts. There's no mechanical parts, rather, or minimal mechanical parts. It's very low operating costs. There's no electricity. So yeah, ideally, that's what they want.
And can you tell me a few of the types briefly? So I've been to North Carolina, and it's got varied topography, right? And as we were talking earlier, septic design is largely based on the kind of soils you have. Are there different types of systems for the respective parts of North Carolina?
Well, yeah, in North Carolina, we have the coastal plain, which is broken up into the upper, middle, and lower coastal plains, and then the Tidewater region, which is really close to the water, and then the Outer Banks. And then moving westward, you had the fall zone, which is where the rapids begin, where the ships were navigating. They came through the trade ships. They had to stop because they hit rock, right? So right there, basically to the foothills, is called the Piedmont, gently undulating topography, deep red soils. But you can have some really bad soils there. There are areas, especially around here, just west of here, called the Triassic Basin. And I won't get into it, but the Triassic Basin's soils are very rough. There's traditionally been limited development of any kind of housing. So then you have the foothills going up to the mountains, and then you have high, medium, and low mountains. And of course, you have riverine systems cutting across. So to answer your question, there are everything's for the most part installed statewide, right? So there are preferences. Things work better in the mountains, such as large diameter pipe. That's what's referred to as a sock pipe. It's long and it's narrow, and it wraps around contour, and it's a corrugated pipe with holes on the sides and the meridians, and it's socked, or it's encased in a fiber, which protects it from the soil material getting in. That works very well in the mountains. It traditionally does not work well in the coastal plain, because the fine sand tends to get in and clog the pores. So there are regional differences, but for the most part, we have grass. I could go in any number of directions you want to. Sorry.
That's fine. So is it fair to say that you need an expert who is regional? Is that a fair assessment? Or, I mean, are there engineers who practice throughout North Carolina designing on-site systems?
Yeah, it depends on your region, right? So the Southeast could be many states in the Southeast, Northeast, but I get your meaning. You need someone who is ideally an expert in your regional or localized conditions or soils, that people that know the soils. People are masters at the soils, that have mapped and looked at thousands of boreholes. And on the engineering side and the design side, people that are address the soil problems. Yeah, ideally you'd want someone with experience in those areas.
So what can people do to keep from messing up their septic system? For starters, go ahead, just if you would.
Yeah. Don't drive over them. Right? Don't park over them. Don't have parties of 30 or more regularly, unless you're inviting me. right? Just make sure, treat it like it's your body, like it's a temple, right? Treat it like no, don't don't flush 3 gallons of milk down. Don't flush bleach down. Know what to do. Know where it is. Know how to maintain it. And sometimes maintenance is just not doing things that we humans tend to do, like flushable wipes. Anything that says flushable, be very wary of, because they might not be. I had a recent event.
So I originally had that in one of the questions. Plumbers, they tell me all the time that those things are a nuisance. It's bad. It's a bad product. You shouldn't be putting that stuff in your toilet.
Well, yeah, it's maybe not a bad product, but it's not intended to go down a pipe into your septic tank, and it's not, that's a pumper's best friend, right? Because that makes them money. That they see that all the time. And
what about the additives, like Ridex and these?
Yeah,
things?
I mean, there's been a study by Mike Hoover in the '90s, I believe, maybe early thousands, that additives have no statistical benefit overall. They do not improve the treatment or function on the whole. You might have a spike of cases, a peak or an outlier anomaly that yes, it does work. You've heard stories that yes, it does work, or no, it doesn't work. We tell people that there's no statistical benefit of adding. So, that's not to say that they can't. They're the homeowner. They're in charge of the system. And it's not going to hurt per se. It's just you don't have to use your money, right? You don't have to spend your money.
But bleach does hurt, right?
Yes.
And solvents, right?
It's all about yeah, and that's going back to your other question that I so expertly circumvented, right? I didn't. No, you want it. If you're doing a thimbleful of bleach, that's probably not going to be an issue. If you're regularly adding bleach to your clothes or you're cleaning, whatever you're doing, if you're flushing it on a regular basis, regular stream of inputs, yes, that will kill the bacteria in the tank. And if you don't have that bacteria, you run the risk. The function of a tank is to anaerobically digest that. And you run the risk of that going up, and you have to pump it quicker and quicker.
Are there general rules of thumb about how often you have to pump? I mean, it varies, right?
3 to 5 years.
That's the longest, right? Some systems would require more often, or is that not a good idea?
Yeah, okay, and we're going down different holes. There's different bunny trails here. If you have a system that requires an operator, you might be having an operator report looking at it on a weekly basis. Yeah. If it's a large system, or if it's a high, if it has a high flow or a high amount of treatment, or more likely an operator coming in once or twice a year looking at it, and they will take core samples and tell you whether or not you need to pump. The big problem with needing to pump, or not problem, but just systems that need to be pumped more frequently, involve grease traps, restaurants. They really need to have an eye.
Or if you have a smaller tank, right? Like my tank dates to the 40s or 30s, I want to say. It's 750 gallons. So they tell me to pump more often. Is that wasted money?
It depends. I mean, in North Carolina, if you have a gravity system, if you have a pump system, you, the homeowner, are the operator. So it's under, you could either hire someone, or you could do it yourself. You could core sample. And this goes back to your previous question. As a homeowner, you need to know where your system is, especially if you have a pump system, especially if you have a shallower system. You don't want to drive over it. Yeah. You don't want your kids going into the tanks or anything like that. So safety first. Just because you have a 750-gallon tank doesn't necessarily mean that you have to pump. It's the amount of solids and scum that accumulate. In North Carolina, they say the rule states if your scum on top plus solids on the bottom is greater than 33% of the total liquid depth, then yes, you need to pump. Or if that scum layer is just, quote, too thick, I mean, you need to pump.
So do you have on-site septic, or do you have a sewer?
Personally, I have a pump system. I feel that if I talk the talk. I need to walk the walk. I had never been on a septic system before. I was always a sewer guy, right? City boy.
How'd you get into this?
I took one class as a soil scientist. I did my undergrad degree at Virginia Tech. Yes, I'm hokey. Uh, and all I took was one class called soil taxonomy. And there's this old school professor. His name was Bill Edmonds, and he took us across the state and he showed us the way. He showed us. We got into groups of there were 60 people. It was his last class, and he got into groups of 6. He called us packs, and this is at Virginia Tech. So this kind of was prepping me for my time at NC State. So I was in a wolf pack, and he said that humans tended to congregate into packs, and there was leaders, and we kind of roamed together. And I had long hair, and my nickname was the Wolf Man. So no, and all it took was one class across the state, and we learn soils, learn landscapes, and it's about the people. This industry, the soil science, engineering, the on-site wastewater, they're colorful people. So I like working with them.
That's awesome. I wish we had more time, man.
Oh, we do.
Are you gonna? Would you come on again? I mean, was this painful enough that you said painful. Never again?
This is not painful. This is not painful at all.
Well, what I'm going to do is ask our listeners to send in their questions to a soil scientist about your on-site septic systems, and I think it would be super fun to have a show where we answered those questions. What do you think? Are you game?
I'm game.
All right, man.
I'm game.
Well, unfortunately, that's all the time we have for today. Thanks to Dr. Erik Severson for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody, and happy building.